Good evening, ladies and gentlemen, and welcome to the SAIEE KwaZulu-Natal Centre webinar on exploratory investigation into big data. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers or panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. The link to the registration is in the chat box. Please register, it's free. A certificate of attendance will be issued a few weeks after this webinar once we have received the CPD validation number from EXA. I'd like to introduce you to our host tonight as Ms. Crystal Anamalai, who's a chairperson of the KZN Centre, and she's employed by eThekwini Electricity MV/LV Operations as a chief engineer and has served the organisation for the past 13 years with her involvement in various distribution automation projects and smart grid initiatives. Crystal holds a BSc Electronic Engineering degree from the University of KwaZulu-Natal and graduated with a Master of Business Administration degree from the University of Pretoria's Gordon Institute of Business Science. She is registered as a professional engineer with the Engineering Council of South Africa and an active member of SEGRE, serving on the SEGRE SA Women in Energy Net Zero Initiative work group dealing with climate change impacts on the energy sector. Over to you, Crystal.
Thank you, Mings, and a very warm welcome to all our attendees that have joined us. And welcome to our guest speaker this evening, Mr. Shandukani Vhulondo. Mr. Shandukani Vhulondo is a senior electrical engineer at Eskom, Transmission Asset Management and Real Estate. He is a registered professional engineer with EXA with over 12 years experience. His professional career spans generation plant engineering design and distribution network engineering design, including transmission asset management and maintenance. He is an MBA candidate with Henley Business School and a member of Eskom Research and Development Digital Incubator, which focuses on the use of machine learning for predictive maintenance to improve asset management with transmission asset management. And that's one of the reasons why we are here today. Mr. Shandukani will be giving us an introduction to his research and some of the findings on exploratory investigation into big data. And I would now like to hand over to Mr. Shandukani. Thank you.
Shandukani, just unmute yourself and please share your screen in presentation mode.
Can you see my screen, Crystal?
We can see your screen, yes, not the presentation.
Oh, okay. Yeah, I'm going to start now. Afternoon, everyone. I'll take you through the exploratory investigation into big data of electric power utility in South Africa. Crystal, is it feasible to put my camera in? I know it's going to take bandwidth, but I am comfortable even without.
Yes, you may. You're more than welcome to introduce yourself here to the attendees, and then you can thereafter share your presentation. I'm unable to see your presentation currently. I do see your screen.
Okay. Let me know if you can see my screen. Just direct me, Crystal.
Okay, I see the desktop of your computer. Not your presentation yet. Okay, I see your presentation. You can put it into presentation mode now.
Just click on display settings at the top and just swap your presenter and view. Yes, in the middle there. Yes, swap presenter view and slideshow. Thank you.
Okay. Thank you, colleagues. I won't even do my introduction. I think Crystal has already done my introduction. Yeah. I'll just skip my introduction. I'm happy that Crystal, you already introduced me. Okay, yeah, this is my agenda. And maybe colleagues, the reason why I've decided to do a research on this and how do I fit in this is that over past 12 years of my experience in Eskom, I've worked in generation and transmission and distribution. So with each division, I've witnessed a lot of use or a lot of sources, data sources from generation, transmission, and distribution. So with an advance in technology, as we move into artificial intelligence, I realized that it is important for one or someone must first do a thorough research on the current existing systems or current state of big data analytics or big data itself within the South African electricity or South African electric utilities, mainly Eskom and municipalities, where they represent maybe 80 or 70% of electricity power utilities in South Africa. This is just an introduction. Cover big data definition, characteristics of big data, primary sources of big data, the forces behind big data and the application, and also the challenges that are facing power utilities, and share some of my results and findings on the research that I've been doing. And I'll also go through the current state of big data in South African power utilities, benefits of big data, and big data for customer billing experience. And I'll also share the barriers in big data deployment, also including the how or solution on the big data deployment barriers. And I'll also share the implementation strategy, conclusion, and recommendation. Rapid increase in fourth industrial technology devices such as advanced metering infrastructures, smart meters in distribution, phaser measurements units in transmission, and condition monitoring system in generation are changing the traditional grid operation and plant operations, particularly in the areas of operations and maintenance. And these are facilitating the adoption of big data analytics tools in South African power utilities, and these are actually themselves, the power utilities, the South African power utilities themselves are finding themselves in an overwhelming increase of this big data that is generated from various power system assets or various sources within the power utilities that I've mentioned in generation, distribution, and transmission. And these long for efficient tools and analytics to effectively leverage on this big data to improve a grid operation.
Shandukani, I think we've lost you. You're probably on mute.
I was saying an advanced semiconductor chips and cloud storage, Internet of Things, smart sensors, 5G, leading electric power utility grid modernization, and further increasing big data generation. More than 30 million IoT smart network sensors have been implemented in the transportation industry, automation, utilities, including the retail sector, and that also including on the financial sector, like a financial market. The electric power utilities around the world are experiencing the major changes, such as just energy transition, climate change, decarbonization, decentralization, and democratization. And these clean energy technologies such as wind energy, electric vehicles, energy storage system. Can you hear me? Okay, microgrid.
Yes, we can.
Okay, thank you. Microgrid, small-scale embedded generator, distributed energy resource are significantly contributing to the increasingly growing of big data in generation, distribution, and transmission to enhance the grid operations, reliability, efficiency, and resilience. The big data has gained a significant breakthrough. The advancement of IoT smart sensors enabling big data analytics technologies, technologies adoption to bring about the prediction of grid operational failures and warn us before the grid can fail, and also maintenance failures, warn us of the failures that could occur in the maintenance or before we conduct maintenance, and also improve the remaining life of an asset. Today, if we look at how this big data has been used, for example, if you look at the healthcare, doctors can classify the cancer patient using big data, coupled with artificial intelligence algorithm to predict if the patient will suffer from cancer using the historical data of that particular patient or historical data of many patients that has been treated under this condition. The question is, what is a big data? Most of the researchers have indicated that the big data is defined as a combination of structured, semi-structured, and unstructured data that organizations collect, analyze, and mine for information and insights. However, the definition of the big data was first coined in 2001. However, it depends on the industry and it depends on the researcher to define what big data is not yet standardized. It is used in an artificial intelligence application such as deep learning, machine learning, reinforcement learning, and predictive modeling such as predictive maintenance. This big data is constituted by three components, which is three data type, which is the first of all, it's your structured, semi-structured, and structured. If we look at what is actually structured data, it's a data that fits well in columns and rows. It's got a defined number of columns and defined number of rows. And the semi-structured data set, it's a data that is a combination. If you look at on the right here, and you might not see, it's an email. So the email can constitute of text. You can also put a photos on the email. So the combination of the emails and your combination of text that you text on the email and the photo that you put on the particular email, or let's say, for example, in the Microsoft Outlook, that combination of data is a semi-structured data. However, the unstructured data, it's a data that cannot fit in the rows and columns. It's a combination of the structured data and semi-structured. So we're looking at the data that is coming. For example, if you look at the data that is generated by Facebook, you see there's a videos, there's a photos, a combination of videos and photos of different range of videos. So those are considered unstructured data. It's a data that needs to have a little bit of manipulation before you can structure it. When we talk about big data, there are several characteristics that resemble the big data. First of all, we've got 3 V's of big data. And the researcher continue to search more characteristics. There's a 5 V's and 6 V's and 7 V's, depending on the researchers themselves. So, but if you look at the basic concept of the big data characteristics is volume. Volume is the sheer amount of data sets or large amount of data sets. So there is a large amount of data set. For example, if you look at today, the data that Facebook generate, it generate over billions of considering the number of users that are on Facebook, which are over billions. So you can imagine how much more data each person is producing per day on Facebook, given the 2 billion people. So you're looking at the more than zettabytes per even minutes or perhaps in an hour. So that is considered a large volume, a large amount of data set. So this large amount of data set can also be translated in the power systems, where you have the phasor measurements units that is currently measuring the currents and voltage, comparing the angles, and check if there's a deviation. So that the next one is your velocity. So we define big data with a velocity. Velocity is the speed at which the data is created or emitted or streamlined or collected. And you will see, if you look at the way the SCADA system is designed within the control rooms or within the substations, the amount of data that is received by the SCADA system or data warehouse or any type of historians within the power systems, it is a sheer amount of data, but it comes at a higher speed. And number 3 is a verity. Verity, it's part of the big data. It comes with a different type of structure. There's so many type of data structured within that big data. We can see we've got some videos, we've got some photo audios. When you go to site, you take some videos, you take some photos, you take some audios, GPS coordinates for maybe electrification designs, for mapping, social network connection. You've got voltage, you've got currents. You also have data in so many formats. So that is a verity. So big data is defined by these 3 characteristics. What are the primary sources of big data within the power utilities? as it fascinated me, looking at the amount of data that the power utility generates, which I foresee that it can be more than the data that some other industry can generate or healthcare can generate. We're looking at the SCADA system. A SCADA system can also be, it's also part of a big data sources. We have a phasor measurement unit that actually monitors the voltage and currents on the grid, and also frequencies as well. We also have a GIS, geospatial or geospatial information system. We also have the smart meters, the distribution level. We also have a asset inventory. We also have some smart application in terms of the building management system. We have the traffic data sets as well. And not forgetting the generator health monitoring condition. We also have a power transformer dissolved gas analysis. And we also have a electronic device, your protection relays. These are the main sources of big data within the power utilities. One can ask, in terms of what you mean in terms of the generator health monitoring condition. Well, in generation, as we know, generation generate electricity. We've got turbine coupled with a gen transformer there. So we do have a panel that monitors the condition for that particular generator. So the data that is generated there can be leveraged for prediction, for predicting maintenance, for predicting if maybe the rotor will fail in the next 2 weeks or in the next month using that particular data set. But if you look at the smart meters, we can also use the smart meter to monitor the energy consumption from the customer side and extract the insight, or learn the pattern of the customer usage and advise the customers to switch off a geyser in a particular time to avoid a higher tariff charge. But when you look at the phasor measurement unit, phasor measurement unit, as I've already indicated, it's a data set that we can use analytics and machine learning and deep learning, to train our algorithm, or to train our machine to predict if there's going to be a disturbance in the network in the next few days or in the next few hours, using the real-time operating data, the voltage and currents that are being sent from phasor measurement to a phasor data concentrator and being sent to SCADA systems or IT, from OT and IT for visualization and analysis there. And when you look at the SCADA system, of course, at the SCADA system, we can visualize. But what is the challenges with all these things that we see? All these things that are called data sources, they can only monitor and control and measure and store and analyze data, but cannot perform the predictive analytics. That is where my interest was, to explore how can this big data that is available in the power utilities and their sources being used to leverage analytics for predictive, to ensure that we can assist in terms of combating the unplanned outages that are happening in the generation, the unplanned outages on our lines, by predicting the failure, predicting if there will be a failure, so that we can put in plant or schedule maintenance in advance before the system can fail, or to predict the remaining life of the transformer before the transformer can fail, and put a proper plan to procure or to do a thorough maintenance or testing on the particular transformers. But the other question that I came across thinking about this was, what are actually the driving forces behind the big data implementation initiatives? Sitting as a senior engineer within the transmission real estate, was part of the research testing and development at ESCO. But my question that came to me was, what are the driving forces? If you look at the way the power utilities are going, power utility are faced by some so-called pestle analysis, where you've got political influence, you've got a technological influence, you also have your social influences. So all these forces are emanating into the forces that you're seeing here. I've got driving forces and restraining forces. For us to implement this big data analytics, what are the forces that are influencing the grid modernization or adoption of these data analytics? We've got a grid modernization, we've got a digital transformation, aging network infrastructure at the distribution level. We also have a lack of grid predictive maintenance and decarbonization agendas. These are the forces that keep on pressing us towards a grid modernization and adoption of the big data analytics within the power utilities to leverage and make informed decisions. However, there are existing restraining forces. The existing restraining forces are the lack of data analytic skills, capabilities. We also have a lack of financial support, lack of financial support, time-consuming activities. We also have the cost of upskilling. However, these are not the major ones. We also have the legacy systems, which play important roles in terms of extracting the data from the historians that are not in interoperability or not connected by new technologies, such as the communication protocols for data and flowing or data transfer or data transmission and communication for various data platforms from different vendors.